Namaste student. Here we have next topic, that is property of whole number, chapter whole number, class 6. So here the first property, that is closure property. Closure means closed. That means if we take two whole number and if we add them, so here 0 is a whole number and 2 is a whole number, and if we add them you are getting here 2, that is also whole number. Then this type of presentation where the operation, that is plus, has been shown here, that means it is closure under addition. We say that closure property is valid for whole number, or you can say that whole number are closed under addition, as well as for multiplication also. Look at here, we have taken two whole number and we are operating here multiplication operation. So 0 into 2 will give you 0. So two whole number and result is also a whole number. By what symbol? Multiplication symbol. Then this type of presentation, we say here whole number are closed under multiplication. But if you look for subtraction and division, you can see here 5 minus 0 is 5. Yes, that is correct. This one and this one is correct. But what about this one? If we'll change the place, and if we'll change here also, see 2, if we'll take here and 0 is this side, you will get 2 only. If we'll take 4 this side, 1 this side, you will get 5 only. If we'll take 7 this side, 5 this side, you will get 12 only. But look at here in the subtraction, 5 minus 0 will give you 5, but 0 minus 5 will give you what? Can you decide? Yes, you will get, you will get a minus 5. But look at here, minus 5 is not there in the whole number, because the last smallest whole number is 0. So if we look at this one also, 1 minus 3 will give you minus 2, which is a what? Negative integer. We'll see in the next chapter. But minus 2 is not there in the whole number. So this whatever result we'll get here minus 5, and here we'll get minus 2. And look at here, minus 5 and minus 2 are not whole number. So we can say that whole number are not closed under subtraction. And similarly for division also, if we'll take 2 by 1, yes, we are getting 2, that is correct. 4 by 2, we are getting 2, yes. But look at here, 2 by 4, we are getting what? 1 by 2. It is a fraction part, and already we have seen by definition that fraction and decimal are not there in a whole number. That means it is also not true. For 1 2 result, it's okay. You will say that, sir, only this type of result. See, to prove what they are not true, one example is enough. So here in words we have, if a and b are any two whole number, then a plus b and a into b are also whole number. So this is your closure property. Now next property we're going to see, that is commutative property. Right now I have told you that 0 plus 2 or 2 plus 0, and if you add them, see here 0 plus 2 will give you 2 and 2 plus 0 will give you 2. Look at this, 2 are true. So if we'll change the place, order, if we'll change the order, result will not affect. 3 plus 7 or 7 plus 3 will give you 11. So 11 plus 8, that is 19, and 8 plus 11 will give you 19. Both are true. And if we look at for multiplication also, if we change the place of the whole number, you can see 0 into 2 or 2 into 0 will give the same result. 3 into 7, 7 into 3, 8 into 11, 11 into 8 will give you same result. But for subtraction and division, you can see that both are not true. 0 minus 2 will give you minus 2, and 2 minus 0 will give you 2. So minus 2 and 2 are not same. This 2 is a whole number, but minus 2 is not a whole number. So for other case also, if you'll see here, these are not true. For example, if you'll see here, 0 divided by 2 will give you 0, but 2 divided by 0 not defined. You cannot take 0 at the denominator place. Means you cannot divide any number by 0. It is not defined in mathematics. So both are not same. 3 by 7 and 7 by 3, both are not same, because 3 by 7 will give you fraction, is not a whole number. So this do not come under your whole number only. So this two result for commutative property does not exist. So in other words, commutative property for whole number is what? If a and b are any two whole number, then a plus b equals to b plus a into b equals to b into a. So what is a and b here? You can take any number. So this is your definition for commutative property under addition and multiplication. These two are property in words, and these are the example. Okay, so whole numbers are not commutative on subtraction and division. Similarly, here we have associative property. So associative property called group property also, and commutative property called order property. Order means you change the place, and here we will not change the place, just we'll take the group different. See, 3 plus 2 plus 0, 3 plus 2 plus 0, just we have changed the bracket. So what does it mean here? See here, if I'll go with this first one, LHS. LHS what? 3 plus 2 plus 0. So 5 plus 0 is what? 0. And for RHS, right hand side, that is 3 plus 0 plus 2 plus 0 will get 3 plus 2 equals to, sorry, here 5 will get, and here also 5. So if you see the intermediate, the middle का step अगर आप देखते हैं, if you see the middle step, you can see that both are not same. Here you are getting 5 plus 0 and here you are getting 3 plus 0, but ultimate result, if you see here, both are same. That means this type of presentation where you can see addition, that is means associative property under addition is true for whole number, and associative property under multiplication is also true for whole number. So let's take this example. Okay, we'll see here the example, that is LHS equals to what? 7 into 5 into 8. And here if we go for RHS, that is 7 into 5 into 8. Now if you see here 7 into 5, what we are getting here? We are getting here 40 and result is 280. And if you look at here 35 into 8 and the result is 280. So here look at the intermediate step, middle step. If you see, you can see that 35 into 8 and here 7 into 40, but ultimate result is same. So here these two property, associative property under addition and multiplication, are valid, but again if you see for subtraction and division are not true. Do by yourself, check with the help of this example, and you can see that these two are not true. So in word, if you ask you to write the associative property for whole number, then you need to write like this: if a and b are any two whole number, then a plus b plus c equals to a plus b plus c, where the first you need to take the bracket a plus b, and for in second case you need to take the bracket here. And if it asks you associative property, then you need to write both case. One is addition, one is subtraction, and after writing this you need to show examples. Here we have the two examples you can show. There are three examples we have. Okay, next we're going to see distributive property. Here we have the first one. Distributive property means if we'll take any three numbers and if we'll take this way, then it can represent like this. That means if I'll take here 3, 5 plus 3 like this, or you can take 9 also, then this can be written as 3 into 5 plus 3 into 9. If we'll take example 3 into 5 plus 9, then it can be written as 3 plus 5, 3 into 5 plus 3 into 9. Let's see that both are equal or not. We'll do here, we'll take LHS. So LHS we have 3 into 5 plus 9. Now 5 plus 9 will give you 14, and if we'll add, you will get here 42. Now if we'll go for 3 into 5 plus 3 into 9, this is your RHS. If we'll check here 15 and 27, if we'll add here, we will get here 42. Look at the intermediate step are not same, but the ultimate result are equal. So this is your distributive property. Additive identity. If a is any whole number, then 0 is the additive identity of that whole number. Like if we'll take any whole number and if we'll add 0 with it, you will get the same result. Identity, जैसे आइडेंटिटी कार्ड होता है, सेम चीज आपका आइडेंटिटी होता है, तो 2 का आइडेंटिटी देखिए 2 ही मिल रहा है, कौन किसके वजह से? अगर आप 2 को 0 के साथ ऐड करते हैं तो आप देख सकते हैं आपको 2 ही मिलेगा. और कोई नंबर ऐड कीजिए, will not get same number. You take here 2 and you take any other number, you are getting 7. See, look at here, we are not getting 2, here we are getting 7, both are not same here. But if you take here 2 and if you add it, you are getting, see here 2. If you add 0 with 3, you can see that 3 you are getting. If you add 5 with 0, you are getting 5. That means 0 is your additive identity. Similarly, we'll get multiplicative identity. Can you guess what number will multiply will get the same number? Yes, you are right. That is 1. Here, if a is any whole number, then a plus 1, sorry, here not plus, here into will take here, a into 1 equals to a equals to 1 into a. Now if we'll multiply here, 1 into 1 will get 1, 5 into 1 will get 5, 7 into 1 will get 7. You can represent this one as like this also, 1 into 5. See, both case will say are same here, and the 7 into 1 will give you 7. So 1 no need to show because both are same here. So this is your multiplicative identity. मतलब आप होल नंबर के साथ कौन सा नंबर मल्टीप्लाई कीजिएगा आपको वही होल नंबर मिलेगा. तो 1 है एक ऐसा लौता नंबर जिससे आप होल नंबर को मल्टीप्लाई कीजिएगा तो आपको वही होल नंबर मिलेगा. तो अगर आपसे पूछा जाए 7 का मल्टीप्लिकेटिव आइडेंटिटी कौन है, आपको लिखना है 1. 7 का एडिटिव आइडेंटिटी कौन है, आपको लिखना है 0. क्योंकि 7 के साथ 1 मल्टीप्लाई करेंगे तो 7 आएगा, 7 के साथ 0 ऐड करेंगे तो 7 आएगा. जब एडिटिव बात करेगा तो आपका आंसर होगा 0, मल्टीप्लिकेटिव बात करेगा तो आपका आंसर होगा 1. Next we have property that is multiplication by 0. That means if you multiply any whole number with the 0 will get always 0. कोई भी नंबर कितना बड़ा भी नंबर हो जाए, if you take any bigger number like I have taken 1, you take here 1 1 1 or 2 like that, if you multiply 0 you will get 0 only. You take any other number like 6315 and you multiply by 0 will get 0. So this is the multiplication by 0. Answer division by 0. Division by 0 does not exist. I told previously only that 0 divided by a divided by 0 is not exist. Yes, if you take 0 divide a, then you will get 0. But if you take a divide 0, that means a by 0. This is not possible. This type of number is not exist. We cannot operate this operation. So this not exist. I hope it is clear to you. Thank you all of you.